Okay, class, here's the first of the three combined gas law problems that I'm going to solve too, rather than just that lady. Now, here we have a gas that's at 110 kilopascals. That's pressure 1, and 40 degrees Celsius. That'd be the temperature of 1. And it fills a flexible container that has an initial volume of 4 liters. That's an L for liters. So that's volume 1. Now, if the temperature is raised to 82 Celsius, that's going to be our temperature 2, and the pressure is raised to 410 kilopascals, that's pressure 2, what's the new volume? All right, well, we've got all three kinds of variables here, so we need to use the combined gas law, which is P1 times V1 over T1 will be equal, or is a constant value, so P2 times V2 over T2 will give you that same value. Now what we want to find here is the new volume. That's V2. So we need to rearrange this equation for V2 first. I've already identified all the different variables. I did it in the problem. You might also make a list. That's fine also, but you do need to keep track of what values correspond to which item in the equation. So rearranging this for V2, back for that. So I got to get the T2 out of here, so I'll multiply both sides by T2. That removes it from there. I got to get the P2 out of here, so I divide both sides by P2. And the P2s cancel on the right, and so I have over here that T2 P1 V1 over P2 times T1 is going to give me V2. Now notice the V2 was on top already. The value you're looking for has to be on the top of any fraction for you to be able to find it with that equation. All right, now we basically plug in those numbers and solve it out. Now we do have one little thing we got to be careful of, the T's. These temperatures are in Celsius. This equation requires Kelvin. So we have to take T1, which was 40 degrees Celsius, and we're going to add 273 to that, and that will give us T1 in Kelvin. So that's going to be 311, or 313 rather. 313 Kelvin. Right? 313 Kelvin. Now T2, we got to do the same thing. T2 is 82 degrees Celsius. We've got to add a 273 to that. So T2 is actually 355 Kelvin. Now the pressures, they're in kilopascals. That's fine. They just both have to be in the same unit. Likewise, the volumes have to be in the same units. If I have liters here, I'm going to get liters over there. All right, now that I've converted those, I can plug those in. So T2 is 355 Kelvin. Pressure 1 is 110 kilopascals. Volume 1 is 4 liters. Divide that by pressure 2, 410 kilopascals, times temperature 1, 313 Kelvin. Now I'm going to put brackets on that in the bottom to make sure I do that right. And if I plug these in my calculator correctly, I'll get that to come out right. So here's what I got to do. Multiply all the top here. 355 times 110 times 4, and then I'm going to divide it by the quantity of 410 times 313. 410 times 313. Boom. Got to make sure I have those parentheses there that I'm dividing by both those already multiplied together. And hit enter, boink, and it's 1.21 is my volume 2. So volume number 2 is 1.22 liters. I think it says rounded to 1 decimal, so that'd be 1.2 liters. And that's how we do that problem.